Interference. So on the subject of interference we have two equations. The first equation is for when we have two slits called Young's slits. The second equation is for diffraction gratings. The first equation on the left, you see we have the fringe spacing, that's the distance between two bright fringes or two dark fringes, which is equal to the wavelength of the radiation illuminating the slits multiplied by the distance between the slits and the screen where you are observing the fringes, dividing by the distance between those slits. The second equation for diffraction gratings, we have the order of the bright fringe multiplied by the wavelength, which is equal to the separation of the slits on the diffraction grating multiplied by the sine of the angle between the 0th order or the straight through beam and the order n. So here we have a diagram of the first equation for Young's slits, and you can see on the left hand side the two slits are separated by a distance s measured from the centre of the slits. The fringe pattern observed at some screen on the right hand side is shown here as light and dark fringes. W is measured as the distance between the centres of two light fringes, which is the same as the distance between the centres of two dark fringes. When we do this practically, it is very difficult to measure the distance between two fringes, so we would measure the distance between many fringes and divide by the number of spacings that we have measured. And D is indicated as the distance between the slits and the screen. Here you can see some examples of two-slit diffraction patterns. On the left hand side, the wavelength was given as 1 square. This is a rather arbitrary unit, but it shows what happens as you increase the wavelength. In the middle diagram we have 2 squares, and the right hand side 4 squares. Where we measure our fringe spacing on the right hand side is where the screen is, and you can see from this quite clearly that if the screen is closer to the two slits indicated by these two black lines on the left, then the fringes become closer together. The biggest pitfall that students have with this equation is being inconsistent with units. If you are given a slit separation in micrometers or microns, and you are given a wavelength in nanometers, then it is safer to do everything in meters using standard form. The second equation is shown here, n lambda equals d sine theta, and on this diagram you can see a diffraction pattern from a diffraction grating which is on the left. In order to elucidate this picture, I will add to it like this. And you can see on the left hand side we have the incident beam incident on the diffraction grating, and some orders of diffraction are visible. I've drawn them in on green. You can see this whole picture is symmetrical between the top and the bottom, and I've only drawn the orders on the top, but there are also orders on the bottom. The straight through beam has numbered order 0, n equals 0. And we increase order as we move further from that straight through beam. The angle is measured between the straight through beam and the order, and I've shown here the angle for the second order in red and the angle for the fifth order in blue. You can see from this diagram that there are 13 spots that would be visible at some distance from the diffraction grating, because there are 6 orders to the top, 6 orders to the bottom, and the straight through beam. Added together that makes 13 spots. Here is that diagram with the equation on the bottom to help you understand how these different variables relate to each other. As before, here are 2 diagrams indicating how the wavelength affects the diffraction pattern. On the left, again in arbitrary units, the wavelength is larger than on the right. And because the wavelength is larger, the diffraction angle is larger, because wavelength is proportional to the sine of the diffraction angle if everything else is kept the same. The biggest pitfall that students have with this equation is D, the slit separation. Sometimes it will be given to you in a peculiar way, perhaps the number of lines per millimetre. D is a distance, so we don't want to know how many lines per millimetre, we want to know how many millimetres between each line on the diffraction grating. So we take the reciprocal of that number, but we do have to be careful with the unit. If we take the reciprocal of 500 lines per millimetre, we get 1/500 millimetres per line. The milli part of millimeters is 10 to the negative 3. So our number is 10 to the negative 3 over 500 meters, or 2.00 micrometers. As before, we must make sure we are consistent with our units. You will sometimes get questions where you don't have monochromatic light, or perhaps you have two wavelengths of light or more, and maybe you're asked for the angle separation between two of the same order, maybe a red and an orange colour beam, and you look at the second order for each and want to know the angle between those two beams. In that case, you calculate your angle for each, and then you take the difference to find the separation. The last important point is that orders are always integers. So our equation n lambda equals d sine theta, when rearranged so n is the subject, n must be an integer. So if we're asked, for example, to find the maximum order, or maybe we're asked to find the number of dots you'd see on a screen in a particular situation, then we need to know what the maximum order would be. The maximum order will happen when the angle between the straight through beam and that maximum order is 90 degrees. So if we set theta at 90 degrees, sine theta is 1, and our equation just becomes d over lambda, the slit separation divided by the wavelength. Let's take an example. If our slit separation is 1 micrometer and our wavelength is 660 nanometers, then that would give us an n of 1.52. But 1.52 is not an integer. The largest integer below this number is 1. We would not round it up. The second order would not be visible. That's simply not possible. And so the first order is the maximum order. So we would see 3 dots on the screen. Most of these questions can be answered by simply making sure we have the consistency of units, plugging our numbers into these equations and rearranging.